All right, so welcome back. I do have a new computer. I do have a new OBS. So if you have any issues with the stream, it worked perfectly earlier today. But if you have any issues with the stream, please go ahead and post to Piazza, post to YouTube, and hopefully I'll see it, and hopefully we can resolve it during the lecture here. But before we go on to the stuff that we were working on last week, strings, and we'll move on to string processing this week. What we're going to do is, I wanted to give you a little bit of a hint and also some direction on what you should be doing with Hack 7. Hopefully most of you have gotten a good chunk of it done already, like 70–80% of it already. But what the most common, oops, there we go. The most common, come on. The most common complaint, or not complaint, but the most common questions we've gotten are on that rotate image. And so remember that the first step to solving a problem is seeing if the problem is already solved. Failing that, though, of course, the second step is to understand the problem. So to understand it, you need to whiteboard it, right? You need to write down an example on a piece of paper, or in this case, on a tablet or something like that, and work through the details. So again, what you're trying to do here, come on, this is not working at all. Okay. Okay. This is unfortunate. No way. It's just not pairing up. Alright, fine. Alright, no. Okay. Completely disconnect it for a second here. It was unscrewed. Can you believe that? The tip was unscrewed, and that's why it was not registering. Okay, fine. Okay. Sorry about that. There. It's now on tight, nice and tight. All right. So, anyway, rotating an image. Let's go ahead and consider what we're talking about here, first of all. Now, unfortunately, this is not a perfect square here. But what you've got is an n by m array, 2D array of pixels, right? Now, what you're trying to do is you're trying to rotate it clockwise. So first of all, what is the dimension of this resulting image? Is it an n by m image anymore? No, what is it? It's going to be m by n now. There we go. Now that's a perfect square there. Right? Now, how do we transfer each one of those pixels over? You need to understand that you've got row I and column J. That's not going to be copying over to row I and column J over here. Right? There's going to be a rotation with respect to that. So let's go ahead and isolate row I here and column J, and let's compute. Let's just think abstractly where that belongs over here on this image over here. Okay. So first of all, what row does it belong on? If I'm taking this entire image and I'm rotating it over so that this side becomes that side, the top now becomes the side, the left side now becomes the top over here. Where is this row going to end up? First of all, what happens to a row? It becomes does it stay a row? Nope, it becomes a what? A column. And if it was row I before, then what column is it now? But not necessarily I anymore. Let's think about that for a second. But let's think about, what about column J here? Column J. What does it become over here on the right-hand side? It becomes a row. And what row does it become? row, it's still row j, right? Because you've taken this thing, you've rotated it clockwise, right? And now it's this thing over here. So we've got I and j originally, right? Now the j becomes my new row, right? So pixel ij becomes row j, but what column is this now? Now here's where you come where you might want to write down an actual example. For example, if you want, let me go ahead and do something like this. No, ugly. All right. There we go. And now let's cut it up. All right. No, we'll make it a 2 by 3 image here. All right. And I'll label these A, B, C, D, E, F. What should it look like now? Okay. I can't draw nicely. There we go. All right, so it should become a 3 by 2 now, right? So 3 by 2. Where does A end up? Top right. Then B, then C, right? This entire first row here becomes the last column, right? It doesn't become the first column. What would that be? That'd be like some rotation and reflection or something, right? You could be counterclockwise there, right? And then it would be A, B, C, so it'd also be in reverse. So it's some sort of a rotation and reflection. What about DEF here? DEF. So the last row becomes the first column. So you can't just necessarily copy those over, right? You have to map them somehow. So let's think about a couple of examples here. What happens when I take row 0? Should become which column over here? The first row should become the last column. So last column. What is the last column with respect to this? Now it goes from 0 up to the size -1, so this is going to be 0, 1, 2, ... What's this last one right here? n-1. Why n? Because that becomes our new dimension for the number of columns, right? So it becomes n-1. What about the second row? The second row is row 1. That should become the last column, which should be second to last, which should be n-2. 2 should become n-3, the second to last, the third to last column, etc. ... And we've run out of room here. But originally, the last row, which is n-1, becomes what column? The first one, which would be 0. So you need to figure out how to score those loops. If you go from I and j, iterating over every single pixel over here in the original image, you have to map each one of those correctly over here. So what should it be? How could I use I, n, and maybe something else here to get this? Yeah, go ahead. N minus, what now? Why n minus first? You need to start, if you start at the first row, then you want to start over here at the last column. And the last column is what? n-1, right? And then there's something in between here. That what you're going to do is you're going to go n-1 minus 0, n-1 minus 1, n-2 minus 2, right? Or n-1 minus 2, etc., right? That's where your I comes in, right? So, writing, I went through this process not to give you the answer. That's not the point. I went through this process to show you what process you should be going through, right? When you're approaching a problem, whiteboard it. This is why we call it whiteboarding, right? Put it up on either, if you don't have a whiteboard, then pull out a piece of paper. If you want to go high tech and use a tablet and start writing out both examples to understand the problem, and then abstracting those examples to the larger abstract case that takes care of everything else, right? Lots of people are having trouble because they are having segmentation faults. Walk through your code on a piece of paper with an actual example. Does it actually reverse, right? Walk through your code on a small example of, say, 3 elements. And does 1, 2, 3 become 3, 2, 1, right? Walk through the code line by line, simulating that. Right? Yeah?
Can you teach us how to use the debugger thing?
That's the next module, but I can show you really quick here. If you want to, it's kind of kludgy in my opinion, but if you want to, you can go ahead, you can use the CS50 debugger. Is that what you're asking, or GDB? Because we'll cover GDB on Wednesday. Or are you asking about the visual one here?
I just noticed it on the CS50
Oh, this thing right here?
Yeah.
Okay, so if you want to get into that, let's see, I have to have some code here to actually work with to debug. Int b is equal to 20, int c is equal to a divided by c, or b, and then printf c is equal to %d and the line, or what? In other words, I'm doing integer truncation here, and I'm not getting the result I expected, right? So let's find out why, right? So if you're going to use the debugger, the CS50 IDE debugger, what you need to do is you first need to set a breakpoint. A breakpoint is, so when you run a program, it just goes all the way through the program. What you need to do is you need to tell it to stop at a location so that you can look at what's going on. So if you want to stop at a location, you can go ahead and double click to the left, or not double click, but single click it looks like, to the left of the line number, and that sets a breakpoint. You can have as many breakpoints as you want, whatever. I'm just going to go ahead and set 1 breakpoint here, okay? Once you've set that breakpoint, then you, of course, need to compile. So gcc demo.c, and remember that much like Valgrind, you need to use this -g flag, right? Once you use the -g flag, all of the variable names, all the method names, all the function names will be preserved, right? Oops, no, cd main, sorry. There we go. Now we're in the correct directory. That produces an a.out. If a.out, if you just run it normally, then it looks like something like this. Now I think the debug 50 a.out, is that how you do it? Yeah. All right, so that starts up the debugger. Right? And again, you have to have a breakpoint set, otherwise it'll just execute the entire program and be done. Okay. Now the debugger on the right-hand side here tells you is a visualization tool. It's stopped and paused execution now on line 10. And what you can do is you can start walking through line by line if you really want to. Or you can take a look at your variables. Over here, A has a value of 10. B doesn't have a value yet because we haven't executed this line. So let's go ahead and execute that line. You've got several options up here. You can step over, which means that you will execute that entire line of code and then go on to the next line of code, which is probably what we want. And you see that B now has a value of 20. It's kind of small, unfortunately, but you can see it if you're running this locally. Okay. You can step into, so if you're about to call a function, you can step into that function and then go line by line within that function. You can step out, step out of the function if you want to continue normally. This resume, it's kind of like it's a continue button. If you've got multiple breakpoints, and I believe that you can set a live breakpoint here, if I resume, it will go all the way to the next breakpoint. Right? There we go. And then you can continue either line by line or I don't know if you can set conditional breakpoints or not. You can deactivate all breakpoints, but you can set conditional breakpoints in GDB, which is what I'll show on Wednesday. Is that enough? Or?
Yes.
Okay. So again, what you would see here is, so it's not a problem with my printing, it's a problem with C, right? Why did that get a value of 0? And hopefully, just simply staring at it, you see, A divided by B, that's an integer divided by an integer, result is an integer, resulting in truncation. But otherwise, debug 50, A dot out. Now, how do you stop it? Well, I think you just let go all the way to the end and it stops itself. You can clear breakpoints by clicking on them again. Right? And then, of course, you can go back to just running it normally without the debugger. And you need to remember that G flag, just like Valgrind. Otherwise, it won't tell you the line number that everything is failing on. Okay? All right, a little bit of a preview from Wednesday, though. Okay? So to continue, we got an online question. Do we trust the web grader for all our outputs in the hacks? I believe so, yeah. It did ask us to make your own tester. We provided a basic starter tester file for you in the repository, so you should be using that. And of course, the image driver itself is an ad hoc tester. Upload your favorite image and try to rotate it, or use the 3 images that we provided. Okay. All right. So string processing. Remember that we were talking about strings, and strings are nothing more than arrays of chars, arrays of characters. The only difference is that whereas if you had an array of 10 integers, right, there are going to be 10 integers in there. But if you have an array of 10 characters, at most, 9 of them can be actual characters. The last one always needs to be that null terminating character. If you do not have that null terminating character, the /0, then you do not have a validly null terminated string. Right? Otherwise, everything that you know about arrays and that you're working with arrays right now can be applied to strings. Not only that, but you have a nice string library to pull from. You can use strcpy to copy one string to another string. Remember that you can't use the assignment operator on strings after you've declared the string. You have byte-limited versions of this, right, where you only want to copy over n bytes instead of the entire string. You also have a string length telling you how many characters are in there, not including the null terminating character. Let's continue by looking at a few other pieces of functionality that you have in that string library. One of them is the concatenation operation. So concatenation is the operation of combining 2 strings together. Right? You append one string to the end of the other. C does not have a concatenation operator. Some languages do let you use the plus operator. C does not. Right? So, for example, in JavaScript, Java, C#, even C++. If you take one string and add it, plus, to another string, that's the concatenation operator. You're taking one string and adding it to the end of another string, creating a new string. C does not support that. Instead, C has a function that allows you to do it. Instead, C provides the strcat function. Now, strcat is short for string concatenation. I agree with you, it looks weird because it should be con, right? strcon. There is another function called strcon that does something completely different, so that name was already taken. strcat is the one that you want to use. Its signature looks something like this. Right? Char star strcat. It takes a destination and a source. It takes the source and appends it to the end of the destination. Right? Just like str is copy, it's a right to left. So it takes the source and appends it to the end of the destination. You'll also note here that these are both strings. Char star is a string. Char star is a string. So one string to another string. But the second one, const, what does that mean again? Constant. And so you're not going to be making changes to that. You're not going to be making changes to the source, but you are definitely, most definitely going to be making changes to the destination. Right? Not only that, but it makes the same assumptions as str copy, right? That you can, it assumes that the source is a validly null terminated string. If it is not, things will blow up. It assumes that the destination that you're trying to append it to is big enough to hold this, right? And if neither one of those assumptions is correct, then it's undefined behavior. So let's go ahead and go back over here to the demo, and let's go ahead and play around with this idea. So I'm going to go ahead and create a string to hold my full name here, right? Full name. And I'll just make it very, very large, just enough to hold whatever I might want to put into it, okay? Now, what's in full name right now, by the way? Who knows? Dead beef, zeros, might be null terminated, but there's no guarantee about that. So let's just go ahead and copy my first name into it. strcpy into full name, my full first name. Now, is full name big enough to hold Christopher? I don't remember how many characters are in Christopher, but yes, 100 should be big enough. Now, what if I wanted to put in my middle name? strcpy, full name. My middle name is Michael. There we go. Is that going to work? Let's find out. What's this going to print if I printed this out? Full name here. So what's it going to print out? Is it going to print out Christopher or Michael and then my last name eventually? Nope, Michael. Right? I'm not Michael. Right? So what was wrong there? I copied Christopher into it, and then I recopied. I overwrote the old string. Right? By the way, HER is still in that array. It's just that Michael has overwritten these Christo, right? And then P has been overwritten with a null terminating character. Right? But otherwise, HER is still there. Okay? So I don't want to copy my middle name. I want to add it to the end, Christopher Michael. And to do that, I'm going to go ahead and concatenate this. Now, let's find out what happens when I do that. Uh-oh. Is that nicely formatted? No. So what's one solution here? I could space it right there, or I could concatenate, full name, a space into it. A single character string is still a string. What do I want to say here? The string containing a space and the space character are not the same thing. These two things are definitely not the same thing. The thing on the left-hand side is a string. The thing on the right-hand side, single quotes, is a single character. The thing on the left-hand side is actually 2 bytes. The space and then the null terminating character right after it. The thing on the right-hand side is just 1 byte, the space and no null terminating character after it because it's not a string. Okay? Those are not the same things. You could not do something like this. The compiler will complain about this. Right? Warning, expected const char, it expects a string, but the argument is of type int. Right? That's because it's a character. Right? And the ASCII text table. There we go. Let's go ahead and compile it now and see if it works. And now there indeed is a space. And if you wanted to, you could go ahead and concatenate my last name, strcat, full name. There we go. And then I'll go ahead and just manually put in a space right there. And there's my full name. Awesome. That's only because it was big enough. What if it was not big enough to hold all this stuff? What if it was only, I don't know, 15? What's going to happen now? Hopefully it's a segmentation fault. Likely it's not. Since it's such a small example, it's probably not going to detect it. Oh, wow, cool. Stack smashing event. I did indeed because I did a static declaration of this, I started overwriting and corrupting my own memory. And the memory that I was corrupting and overwriting was the stack memory. And if you start screwing around with your own stack frames, then at least in this case, it was able to detect that, and I smashed my own stack. I destroyed my own stack memory and corrupted it, and it aborted it. So let's go ahead and make it sure that it's big enough to hold that stuff. And it should work now. There we go. All right, that's the process of concatenation. And like strcat, it also has an strncat, a null byte limited version of it. So if you only wanted to copy over only a certain number of bytes, for example, I don't know, I'll go ahead and copy only over my first initial, the first initial of my last name. There we go. strncat. Now let's go ahead and see if this works or not. Christopher Michael B, right? I only copied at most one character over. Now be careful, because just like strncpy, let's go back to our assumptions on this. It copies at most n characters, or in this case, concatenates at most n characters to the destination string. If the null terminating character occurs within those first n characters, then it will be copied for you, and it stops. It copies at most n characters. If it is not within the first n characters, it will not copy over that null terminating character for you. So I said copy over at most 1 byte. There's the byte that it copied, the capital B. Did it see the null terminating character? Nope. So what I should be doing is I should be concatenating that, I should be taking care of that myself. Right? Now there's no easy way of doing that here, but be aware that you have to do that in general. All right, let's go back to my full name. There, restore that, and there. Put in that space so it's nice. Okay. All right. Another piece of string processing. Oftentimes you'll have to deal with what are called substrings. So a substring is simply just a part of a string. Right? You can say start at this index and then consider the string all the way to the end, or you can say I only want from this index to this index, kind of like a subarray, right? There is no substring function in the string library, but you can use a combination of pointers and strcat or strcpy to get the same effect. What I mean by that is let's go ahead and go back over to our demonstration here. And instead of copying over all this stuff, let's just go ahead and start out with my full name already done. Right? So what I want is my short name, CHRIS. Right? So 5 characters. Why would I create an array of size 6 to do that? What do I need at the end of a string? The null terminating character. So let's just go ahead and copy my short name into this array here. Right. There we go. So let's go ahead and try with strcpy first of all. Copy into short name my name. Is this going to work? Can you fit Christopher Michael Burke into an array of size 6? Nope, you can only fit CHRIS and then the null terminating character. So we don't want strcopy, we want strncopy. And I want to copy at most the first 5 bytes. Why the first 5? If I copied all 6, what would it actually copy? CHRIS, T, leaving no room for that null terminating character. So let's see if this works, first of all. And it does, it seems to work. But remember the behavior of strncat and strncpy. Does it put that null terminating character in there for me necessarily? Did you see that null terminating character within the first 5 bytes here? See, ILIC is CHRIS. So I need to put it in there manually. And in this case, I know exactly where to put it, right? At index 5. Actually, is it at index 6 that I put that null terminating character? 0, 1, 2, 3, 4, 5, and then 6. That would be a 7-character array. You're always starting at 0. So it should be at 5. And now this is guaranteed to work. It seemed like it worked before, but now it definitely works. I also want to do the same thing with my middle name. So let's go ahead and create another string for my middle name. How many characters do I need for that? 1, 2, 3, 4, 5, 6, 7, 8 to accommodate for the null terminating character. All right? And now let's go ahead and copy into my middle name, my name, strcpy, into middle name, my name. But I will limit it to 7 bytes because that's all I want to copy. All I want to copy is Michael. Okay? And then I will put in another debug message here to put out my middle name. And by the way, you need to take care of that null terminating character. So where should that be? At index 6. Now, is this going to work? Oops. What are you complaining about? Oh, thank you. strncpy. There we go. What's it going to print? It's going to print hello, Chris, and then hello, Christ, right? Or Christ, whatever, right? That's not what I wanted. What I wanted is a substring starting at this location right here. So where is that location? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. In other words, I don't want to copy name. I want to copy the string starting at name of 12. We might be off by 1. We can see where we go if we need to adjust. Right? I don't know if I lost count there or not. Right? Is that going to work? Let's try to compile it and see what the compiler says. strncpy expects a string. What did we give it? A character. Name is a string, right? It's a char star. But names of 12 is 1 character in that. Just like an array of integers, ARR, that's an array pointer, int star. But if you look at one of them, ARR sub 5, right? Then that's only 1 integer. So this is only 1 character. How do I take a regular old character and turn it into a pointer? How do I take a regular old integer and turn it into an integer pointer? Ampersand. Right? Star is the dereferencing operator. So again, you'll just get used to it back and forth. Right? I always liken it to when I was an undergrad and I took calculus, and the derivative of a sine, is it cosine or negative sine? Derivative of cosine, is it sine or negative sine? I never remembered it, so I always put it up on a post-it note. And then eventually, by looking at that post-it note back and forth, and using it on a regular basis, it just drills into your head. Although I still don't know what the derivative of sine is. Right? It's one of those things that once you're done with it, you forget about it. Why should you have to memorize that to begin with, right? All right, so let's go ahead and run this now. And it's I was off by 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Oh, thank you. So I'm cutting off my L there. Right. But there we go. Here's Michael. Right. So you can do a substring by a combination of limiting your copying or limiting your concatenation, but also by starting a string at another location. If you've got a string here, well, that's where that's the usual beginning of a string. But then if you want the 12th character, in this case the 13th character, then you can jump to that index, use an ampersand, and treat it like a string that starts in the middle instead of starting at the very beginning. Right? I'll go ahead and push this into the notes so that you can see this, or so that you have it. Right? There we go. All right. There's also other convenience functions. other convenience functions. So for this, since it was already covered by Zybooks a while ago, but I like to recover it, reiterate it in the context of strings, you have the CType library. CType is just the language C and then types. And it provides a lot of functions that can operate on a single character instead of an entire string. And by the way, we've only gone over a small fraction of the string library functionality. If you ever have a question of, well, is there a function in the string library to do this? RTM, Google it, right? And find out what functions are provided by the string library. You'll find that there are lots more useful functions than just the ones that we've covered. Right? But otherwise, the CType library allows you to operate on single characters. Is alpha, if I gave it a character, this would return true if it's an alphanumeric character. Lowercase a through z, uppercase a through z, and I believe 0 through 9 as well. Is space returns true if it's a space, if it's a tab character, if it's an n-line character, or if it's a carriage return, right? Is upper or is lower returns true if it's an uppercase letter or a lowercase letter, respectively. Generally, for all the umlauts and all of the punctuation, like an exclamation point or a question mark, these are gonna return false. There is actually another one called is_punct, and that will return true if it's a punctuation character. And again, I'm not covering them all because you can go ahead and read the documentation and find out what it provides. But you can also convert things. Convert a lowercase character into an uppercase character. Ask whether or not if it's just a digit, 0 through 9. I don't care if it's A through Z, if it's just the characters 0 through 9. So lots of useful functionality in that library as well. You can also do basic string formatting. So printf, you can do this really easy when you print it to the standard output, right? Printf will format a result to the standard output. There's another version of this called sprintf. What do you think that S in front of it stands for? String. It will format a string and print it to another string. Right? Basically a string buffer. So let's come back over here to my my demonstration, and let's take a look at what this looks like. Right? So let me go ahead and create a couple of things here. Int a is equal to 42. Double b is equal to 3.14. Right? Char name is equal to Chris, right? Et cetera, et cetera. So I've got 3 variables here. If I wanted to print this in a nicely formatted manner to the standard output, I would use printf, right? Hello, %s for a placeholder for a string. Your number is 42, right? %d for an integer. Pi is %f for floating point numbers, right? And I would provide name, a, and b. Now, when I run this, of course, you can expect what the output is. It's going to be nicely formatted here. But if you want to, that prints it to the standard output. What I want to do is I want to print this to a string. So I need a string big enough to hold it, first of all. So let me go ahead and call that result. And I'll just make this a giant string, 1,000 characters. Otherwise, I would have to go through this thing and count up the number of characters that are in it. And that this placeholder is going to be replaced with CHRIS, so that's 5 more. And then this is going to go out to 6 decimal places, plus the period. I don't want to have to worry about those details. I'm just going to make it big enough to hold the result. Now, to print to the string, I use sprintf instead. Okay? And it's a little bit different. It's exactly the same as before, except for there's a new first argument. That first argument is the string that you want to print to. Right? If I ran this, it would look exactly the same, by the way. Right? But the result would now hold this formatted string right here. To prove that to you, let me go ahead and print it out. Printf. The result is equal to %s and the line result. And when I run this, you'll see 2 copies, except for result is in the front of it. And why am I getting a blank space here? Question. I formatted the string with an endline character. When I printed it, I put in another endline character. Right? So that's why I'm getting that. It's just a double endline character. Okay? So sprintf allows you to print to a string. Everything that you know about printf, all the tricks and tips that you've picked up this entire time, they can be used with sprintf as well. There we go. All right. All right. And lastly, tokenization. Often data is given in a textual, but formatted manner. So CSV or TSV. Right? These are known as flat files. We'll talk about each one of these in a second here. What about CSV? Have you ever heard that term before? CSV. I'll give you a hint. Something separated values. Comma separated values. Right? If you were to, in an Excel file, if you were to say that Excel is a proprietary format established by Microsoft, etc. But if sometimes you were given a textual data, well, if you've got like a first name, last name, major, GPA, NUID, how are you going to separate each one of these pieces of data? You need a separator, and in this case, it would be a comma. There's alternatives like TSV. What do you think the T stands for there? Tab, right? So here's the first piece of data, tab. Second piece of data, tab, etc. These are all known as flat files. They take a data format and then they flatten it out on one piece of paper, right? Where you've got rows and you've got columns. And each line is one record. Each line is one row. Each column is separated by either a comma or a tab or something else entirely. What we want to focus on are comma-separated value types, okay? Although it'd be pretty easy to extend what we're about to do. So for example, here's my data. My first name, last name, my NUID, where I live, Omaha, Nebraska, and finally my office number, 103 Shore. Note there that there is one space. Right? Can we have space-separated data? We could, but then would I be able to put in a space in an address or something like that? No. How would we disambiguate whether or not this is a space that's part of the data or a space that is a delimiter of the data? We have the same problem with CSV, by the way. What if I wanted to put in a comma in the data? I would have to escape it somehow, or I would have to use a different placeholder value for it. We won't get into that. These are known as tokens. Each piece of data is a token, right? And it is separated by a delimiter. And in this case, the delimiter is going to be a comma. What we want to do is we want to split this data out so that we only look at token by token by token. Right? And that's what the operation is called. It's splitting it out. You split this data into separate tokens and process each one by itself. Right? This is known as tokenization. And we tokenize it. We split it up and into each one of these tokens. C provides a function called str toke. What do you think the toke stands for? Tokenizer or tokenization or whatever. Here, and it's in the string library, by the way, as with everything that we've been talking about here. There is the signature for it. So it takes a string as its first argument, and then it also takes a string as its second argument. By the name of the second argument, delim, what do you think that is? That's the delimiter, all right? The first argument is the string you want to tokenize. Right? The second argument is a string containing any and or multiple, if you want to, delimiters. So if you want to specify that commas are delimiters, spaces are delimiters, and I don't know, tabs or delimiters. You can do that if you really want to. We will not have cause to do that in this course. Instead, we're going to stick with one delimiter, probably a comma. All right. Now, the way that you use this is not like a lot of other functions that you've used before. The return value is the next token. Right? So what I'm going to do is I'm going to call this function multiple times. I'm going to call it the first time, and it's going to give me the first token. Call it again, and it gives me the second token. Call it again, and it gives me the third token, ... until it ends. Right? The first call, you pass in the string you want to tokenize. Right? Each subsequent call, you pass in null for the first argument to continue the tokenization. If you pass in a new string for this, a new non-null string for the first argument, it starts over and starts tokenizing that string over and over again. Okay? How do you know when it ends? When there are no more tokens, strtoke returns ... What do you think? Well, what's the return value here? Char star. Could I return -1? No, sorry, there are no more tokens here. Nope, why? Char star is a pointer. It is a memory location. Is -1 a memory location? Probably not. Right? Certainly probably not one that belongs to me, even if it does exist. So what's the only thing that you can use as a flag value to indicate this is not a valid memory location? Null. Right? It returns null to tell you no more tokens, move on. Right? All right, let's go ahead and play with this data then. Right? Come back over here to this demonstration. There's my data, and I want to tokenize it. So what we're going to need is, first of all, a character pointer to point to the current token. I'll initialize that to null. Let's call strtoke the first time. strtoke. Now remember, what is my first argument? It's the data, or the string, that you want to tokenize. The second argument is what? The delimiter that you want to use. In this case, since this is CSV data, what should I provide? A comma. Right? Now you need to capture this return value. So current token is equal to strtoke of this data. Now let's see this in action, and let's see it print out. Printf token equals %s and a line current token. There we go. All right. Let's run it, and you see that Chris was the first token. Did it include that comma there? Nope. It takes the delimiters out. Right. So note. strtoke will not include the delimiters in the token, which is a good thing. They're delimiters. They're not part of the data. Right? They're separating the data. Right? But as a consequence, in fact, I'm going to put that into bold. Bold and underlined? Or bold and italic. Right? As a and I got to spell it correctly. Consequence. There we go. As a consequence, it changes the string you give it. Understand that. Let's go back up to the signature here. That first argument, the thing that you're tokenizing, is there a const in front of it? Nope. That should be just as much of a red flag as having a const there in the other two were. In this one up here, where we're saying const char star, we're making a promise that we are not going to change it. The lack of a const keyword is also sort of a promise. I am going to change it. So if you don't want the tokenization process to change your data, you need to make a deep copy of that string. And we did that last time, remember? We created a deep copy string function. You might want to start using it. Okay? As a consequence, it will change what you give it. All right? Now let's go ahead and get the second token, my last name. Let's try this. I'm going to call strtoke again on the same data with the same delimiter and then print it out. Predict what this is going to do. It's going to print out Chris. What do we want it to do? We want to print out my last name, Burke. But that ain't what it does. Why does it print out Chris again? I should have changed this to null, right? All it did, when I pass in the data for the second time, it starts the tokenization process over at the string that you gave it, data. Right? If you pass in null, then it remembers that it already processed Chris, already took out that comma, and here's where I need to start my token, the next token. Right? And this should work if I save it. There we go. There's the next token. And the next token. And the next token. Next token, next token, next token, next token. I don't know how many times I copy pasted, but should I have done that? Probably not. Let's find out what goes on. Right. So, Chris, Burke, my NUID, city, state, and then office number here. And then null, null. Oh, okay. Sorry, I shouldn't have done those last two. Right. Why does it print out null? Because it returns null. Right? There's no next token because it's reached the end of this string and it's done. It's not going to result in a segmentation fault unless I try to do something with it. But it is, that's a signal that that's the last token. What should I have been doing instead of copy pasta, copy pasta, copy pasta? Oh, a for loop? A for loop would work if I know exactly how many tokens I want. What if I don't know how many tokens there are? A while loop, okay. So, while some condition, what I will do is I will call strtoke. Right, current token. And on data every single time and then print it out. I'm not processing the data right now. All I'm doing is just printing it out. So let's get this to work here. There we go. While what condition? While I still have a token to process, right? How do I know if I still have a token to process? If it's not null, okay, the current token is not null. Yeah, it starts as null. So what's going to happen if I run this program as is right now? It doesn't do anything, right? It doesn't even do the first iteration of that. So here's an example where if you have a while loop and that counts to 10, where did you initialize I? Did you initialize it inside the loop? I is equal to 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10? No. You initialized I before the while loop. And that's what I need to do with current token. There we go. All right, no questions online there? All right, is this going to work? Okay, we'll predict what's going to happen. Going to run forever on that first token.
You need a break.
Oh, we all need a break. It's on Monday and Tuesday next week. Right. But anyway, no. What do you need to do on this each subsequent call? You need to pass in null. And let's see if this works now. Excellent. Except what? Do I process that first token, Chris? Nope. And I'm off by 1 on the tail end too, right? So I'm off by 1 on everything. What should I be doing instead? Where should that print statement be? Up at the front. Chris, print, next token. Burke, print, next token. Excuse me. And now that's on. Right? Now, if you did have some upfront a priori knowledge about the data that I'm expecting 10 tokens, then a for loop would work perfectly fine too. except when you've got corrupted data when there's only 9 tokens, right? Or there's corrupted data and there's 11 tokens for some reason, right? This one ensures that you can also do some error checking. What are the expected number of tokens here? One, two, three, four, five, 6, right? And what I can do is I can keep a counter. Int count is equal to 1, right? And in addition to token, I'll print out the count there. Count. And then I read another token and I count up. See that work? Tokens 1 through 6. And I can check at the end if count is not equal to the num expected tokens, then printf error. I think it might print error anyway here. We'll talk about why here in a second. Why does it print error? Think about that last token that I read. 103 shore. We print it out. Then I count up. One more. So I'm off by 1 here. What should I do to correct for that? I could subtract 1 over here, right? Or I could add 1 over here, and now there should be no error. There we go. Or I could ask if count is not equal, that checks on both ends. If there are fewer number of tokens, if there are more than number of tokens, then I can print out an error and then quit or handle that however I want to. Okay? All right, any questions on this so far? Then let's go ahead and play around with this a little bit more. What if I had a delimiter of a lowercase o? What would the tokens be now? Well, the first token would be CHRIS, comma, B, and then there's the first delimiter. And then it would keep going until it sees, what about that O? Omaha? Nope, because that's a capital O. All the way to the end and then to shore, so the last one would be ORR. Right? There we go. If you want to have multiple tokens, lowercase o's, big O's, and commas, you can do that if you really want to. And now it'll be all over the place, right? On all of those, right? So you can have multiple tokens if you want. On each subsequent call, if you want to, you can use different tokens. So the first time I do it, I'll do O's and big O's and commas. But each subsequent time, I'll just do commas. This will be even weirder. There we go. Nope, because I see the first comma here before the first O. So let's do, I don't know, capital C as well. Oh, no, capital, or R. There we go. And there, it cuts across Chris. All right? Questions on this so far? Again, it does change the original string, right? So let me show that to you, what I mean by that. Printf, the original data is ... and the line. And what we're going to do is we're going to manually print each and every single character. So for int I equals 0, I'll only go up to 50. I don't know how big it is. I++. Printf, what is it? Data. There we go. Data sub %d is equal to %d c, excuse me, and the line I, and then data sub I. Let's see how it's actually changed the original data. There we go. And there's all the tokens, and the original data is Chris. What's here now? This is not a space. It is a null terminating character. I guess it doesn't look good because it's not being printed. But let's go ahead. And, what I'll do is I'll print the integer value of that character as well, right? And I'll cast it as an int here. And I'll prove to you that it's actually 0, not the space character. Does anybody know what the space character is off the top of their head? I think it's 32 or something, I forget. Right? Is it 32? Okay. All right, here. CHRIS, and then the null terminating character, which has an ASCII value of 0. Burke, null terminating character. My NUID, null terminating character. Omaha, null terminating character, all the way down to the end here. And then we've gone past the actual string, and you see that we've got -85, which is not in the ASCII text table, and that's because it's garbage stuff that was filled in before. Oh, okay, yeah. We haven't talked about fprintf yet. There was a comment online to use fprintf. You might have seen that before in some of our code as well, to use fprintf and then to the standard error instead. We haven't gotten there yet because we haven't covered file IO. Right. But so printf prints to the standard output. Sprintf prints to a string. What do you think fprintf prints to? What do you think the F stands for? A file, right? We're not there yet though. Okay. I'll put this into the notes so that you have it to work with if you need to. And last thing that we'll cover on strings. And then we'll have a wrap up on Wednesday. What I'll do is I'll demonstrate, well, I can demonstrate the debugger again, but I will demonstrate GDB because it's a more powerful debugger. And then with whatever time we have remaining, I will go over last year's midterm. I don't know if they announced it or not, but if you are part of the plant group, Plant CS, they'll also be, their meetings this week, they'll also be going over midterm review. Right? So they'll just be pulling out old midterms and doing them. Right? All right. It was today, or it is today. Okay, so it's gone. Then there's one tomorrow. I don't know what time it is. I don't know. They never made an announcement on Piazza. I don't know why. Right? But anyway, because you went to the first one, maybe. Oh, you didn't? Oh, okay. Then they're communicating off Piazza. I don't know why. All right, but whatever. So in C, strcmp is used to compare the contents of two strings. And this is going to come in later on when we start doing searching and sorting. This is a comparison function. It has a contract, basically. And why do you have to even use this function to begin with? For integers, you can use the equals equals operator, right? Int a is equal to 10, int b is equal to 10, and we could go if a is equal to b, right? Printf equal. That's because they're integers. Can we do that with strings? Let's find out. Char a is equal to hello. There we go. Char b is equal to goodbye. There. Let's try it. And I do want some to print out something if they're not equal. So not equal. There we go. Compile it. Run it. And they're not equal, so it seems like it works, right? Okay. Let's test. What if they are equal? Hello and hello. Those are the same strings, right? We should expect them to output that they're equal, right? It doesn't. Why? Because this is a numerical comparison operator. What is A again? A is a memory location. It's a pointer. There's an integer of value associated with that memory address. And so you're asking the question of, is this memory address equal to that memory address? You're ignoring completely the contents of those two strings. That's why you can't use the equals equals operator, because it doesn't do what you expect it to do when you've got strings. Right? That demonstration, there you go. So it compares memory addresses. To properly compare the contents of a string, you have to use a comparator function. This is not a real world. This is not a real word. This is a malaphorism that computer science uses. A comparator function. It compares two things, and it has the following contract. First of all, it takes two strings, A and B, and if the contents are equal, it returns 0. if A comes before B lexicographically, what does lexicographically mean? Alphanumeric, right? In other words, apple comes before zebra, right? It returns something negative. If A comes after B, again, lexicographically, it returns something positive. Right? Now think about this. I've got A and I've got B. Is that the order? A comes before B, then it returns something negative. If they're equal, it returns 0. If they're out of order, it returns something positive. Now, why does that order matter? Think about the number line. Negatives, positives, and what's in the middle? 0. So if they're in order, think about that number line, right? Negative. If they're out of order, positive. Otherwise, it's 0. It's basically the difference between two numbers on the number line. Okay? That's the way that I like to think about it. Right? And again, it returns something negative or something positive. There's not much that you can read into that actual number. Instead, you need to just use a numerical comparison operator. So once again, let's go ahead and change this code. So if strcmp of a,b is less than 0, that means that the first string comes before the second string. Right? Else if strcmp of a and b is greater than 0, then that means that the first one comes after the second one. Otherwise, what happens? Equal. Okay? Now let's go ahead and try this. What should it print out? That they're equal. Now it works. Let's try some other things here. Apple and banana. Which one comes first? Apple comes before banana. Right? Banana comes before apple. Okay. Which one comes first? Apple or banana? With a capital B. Oh, why are you saying banana? The ASCII text table. All the caps, all the capitalization, all the capital letters come before all the lowercase letters. That's why I said it's lexicographically, alphanumerically. It's not alphabetical. It's not like a dictionary. In a dictionary, uppercase A's would and all the lowercase A's, they're all intermixed. Then B's, regardless of capitalization. Then C's. That's not how it works here. It's lexicographically. Right? Apple, lowercase a, comes after banana, because all lowercase letters come after uppercase letters. What about apple and banana? Both uppercase letters. Apple now comes before banana. Right? What about apple and apple? Which one of those comes first? The all uppercase apple comes first. Right? What about 1, 2, 3, and actually no. Let's go with 9 and 1, 2, 3. That's in order, right? 9 comes before 123. If they're integers, that's true. But are these integers? Nope. Which one comes first? 1, 2, 3, 4, 1, 2, 3. Why? Because 1 comes before 9 in the ASCII text table. Right? This is not the same order as numerical order. It is not the same order as a dictionary. It is lexicographic order, according to the ASCII text table. Right? So what comes first? The end-line character or the exclamation point? I think it's the end-line character. Yep, the end-line character comes before the exclamation point. Right? What about apple and apples? Which one do you like the better? Are they equal? Apple and apples? Nope. Apple comes before apples. Why? It's shorter. What is that last character that it compares, by the way? Apple, and then what's the last character after it? APPLE, null terminating character. Where's the null terminating character in the ASCII text table? All the way at the beginning at 0. That's why it comes before anything. And that's why shorter strings that are otherwise equal come before longer strings that they're a prefix of. All right, we'll have some more fun with that on Wednesday.